we want to look at something called conditional probability. Now, we've already looked at the addition rule as well as complement and just basic probabilities. Now, with conditional probability, what this is we already know something about the object that we're selecting or the object that we're getting, the event that's happening. So there's some information that we know. I'm going to go ahead and give you the formula, and the formula is going to look really strange and probably not going to make a lot of sense at first, but let's go ahead and look at the formula. It says that the probability of event B, so whatever we want, given this line right here means given event A has happened. So this right here is what we know. Okay? So this is the information that we know. This is equal to the probability that A and B happen. So like their intersection, they happen together, divided by the probability that event A happens. Now, another way that I tend to look at it a lot of times, especially if we are looking at things like a contingency table or things of that nature, I look at it as the denominator is the number of given. So in other words, if you know something, if something is given to you, how many are in that given? And then this right here, the numerator, is the number in the intersection, okay, so to say. Let's look at an example, and I'm going to start with the car types because you can really see it in the contingency tables when you're looking at them. Let's say that I want, first of all, let's look at just the probability of a Toyota and a sedan. Okay? So I want to look at Toyota and sedan, the probability of that happening. Well, I don't know any information at this point, so my denominator is going to be 152, and the number of sedans and Toyotas, so that's going to be Toyota and sedan, so there's 8 of those. And then I do the 8 over 152. I can simplify that into 1 over 19, or that's going to be a 0.053. That's the and, which we talked about a little bit when we were talking about the intersection. So anytime you have just an and, it's where those two things intersect. Now, when I want something that's given, so I want the probability that the car is a sedan given I know that it's a Toyota. So if I know, given that it's a Toyota, remember that's what this line means, is I want the probability it's a sedan given it's a Toyota. So if I know that it's a Toyota, basically I'm marking everything else out. I don't care about anything else. So if I've marked everything else out, I only have 45 cars to select from. So if I only have 45 cars to select from, that now becomes my denominator. I don't care about all these others. I already know that it's a Toyota. Say I got it off the Toyota dealership lot, okay? Or I can see the emblem. I know that it's a Toyota. So it can't be a Ford, so those 35 are out. And it can't be any of these, so I no longer have to worry about that 152. I have narrowed down my selection. Then I look at, okay, how many of those are sedans? Okay, so here's the sedans. I have 8 of them. Well, what did we say was my numerator? It's where they intersected, Toyota and sedan. Yep, there it is. But this time, I have 8 over 45, which gives me 0.178. So there's a difference as far as what we have. Now, it definitely changes if I know different information, because let's say that I know, let's say I want the probability that it's a Toyota, given that it's a sedan. Now, I know that it's a sedan, so I know it has to be one of these right here, so I don't have to worry about the SUVs, the coupes, the trucks, and the hatchbacks. So now my denominator becomes 29 instead of 45. My numerator is still going to be 8, but my denominator has changed because I know something different about the object. And so I get a 0.276. So notice changing the order changes that denominator. The second thing is your denominator. Whatever is given, whatever we know about the object, is on my denominator. This is the prime example of a guess who game, because you start out with all of your possibilities, and then you ask yes or no questions. Does the person play golf? No. Okay, so I can mark Phil off, I can mark Madison off, I can mark Julie off. So I've eliminated 3 people. So now my denominator is no longer my total 30. Given I know this person does not play golf, I now only have 27 to select from. So as you choose or ask questions, is this person wearing a yellow outfit? Yes. Okay, well that helps me a lot because that eliminates these, all of these, all of these. Okay, now notice I have 1, 2, 3, 4, 5 to select from. Okay, I know that they're wearing yellow, so now I only have 5 to select from. And then I can go from there. Does this person ski? No. Okay, so I can eliminate Katie and Guy. So my probability changes with every single question. My denominator doesn't stay the same in the Guess Who game. The probability is constantly changing. You no longer have a 1 out of 30 chance of getting the correct answer. every time you ask a question, your chances change, your probability changes, because it's a conditional probability. You know something about the person. So I want you to see if you can practice some of the conditional probability, and then let me know if you have any questions.